Welcome back. It's Marlon Echeverry here at the Natural and Social Science Tutoring Lab here at Miami-Dade campus, the Kendall location. Today we're going to finish up with balancing double replacement reactions. This is the final step and the final video in the series. Let's go ahead and take a look at what we've done so far as solving double replacement reactions. So when we first started, we did rearrangement, where we simply had to take the initial compounds and rearrange them and then properly arrange them on the product side, and there were some rules involved with that. In the second step, we had to make sure to crisscross our products to make sure that we would get the correct subscripts that we had to work with. In the particular examples that we've worked with, they canceled each other, so they actually did not change the equation. In the third step, we were checking the solubility of our products, and we were remembering this very important principle that if you don't form at least one weak electrolyte, then that there will be no reaction. Remember, that's a pretty important principle. Here are the solubility rules that we followed in order to determine whether or not our compound was actually soluble. And now we get to the final step, which is just simply balancing the reaction. Hopefully at this point you've practiced balancing quite a bit. Balancing, it gets easier as you practice, and once you get to a certain level, this will be the easiest part of the entire process. So let's go ahead and look at our examples and try to balance those. This shouldn't be too bad. So in our particular example, we have our sodium chlorate here and our strontium sulfate. You can pretty much balance this almost by just observing what you have. Hopefully you're at that level where you can just look at this and you can realize that this 2 from the chlorate will significantly affect things. So because we have this 2, that means that I have 2 entire units of this chlorate. While on the right side of my equation, I only have 1. So what do we clearly need to do? Well, we need to balance that. It's an imbalance. I'm going to go ahead and use black. I think that'll be nice. It'll come out clearly. So what we always do in balancing is we put a coefficient in front of our compound. So let's go ahead and do that now. So I'm going to go ahead and put a coefficient here of 2. And what this 2 signifies is that I now have 2 chlorates, but you have to remember one of the most important principles, that as soon as you put a coefficient, that coefficient is going to go and be distributed among the 2 elements. So this applies to the sodium and this applies to the chlorate. This was covered extensively in the balancing video, so if you guys are curious and unsure of how to do this, make sure you take a look at the previous video that we have on balancing reactions. But that is one of the key ideas. But that's okay, so this means that we have 2 sodiums and 2 chlorates. The chlorates are now done, and now I look at the sodium and I see that I have a 2 here as well. So I realize that that's perfectly fine. This is balanced. As far as strontium is involved, I have 1 here, and I have 1 here, so that looks fine. As far as sulfate is involved, I have 1 sulfate here, and I have 1 sulfate here. So this reaction is completely balanced. If they were to ask you for the sum of the coefficients, you should know that you have to put a 1 on all the blank ones. So if they asked for the sum of the coefficients of a double replacement reaction, do not forget to make sure you put a 1 in front of here. So I would go ahead and put a 1 here. I'd go ahead and put a 1 here as well. And then of course over here. And this would be a completely balanced reaction. And I could see that the sum of the coefficients would be it'd be 5 in total. Okay, now let's look at our second example. In our second example, you can start with this piece here. You see that you have 3 complete units of acetate. You see those the 3 here? That means that you have 3 whole units of acetate. On the right side, I can see that there is no parentheses, so that tells me that there's actually an invisible 1 surrounding this, invisible parentheses 1, which means that I only have 1 complete unit of acetate. So what this means is that I'm going to have to put a coefficient here. So let's go ahead and do that. The only thing that would balance this appropriately would be if we were to go over here and place a 3 in front of that. So if we put a coefficient of 3, you should know instantly that that means that we have to distribute that coefficient, correct? So let's go ahead and distribute that. So you know that this means that you have 3 ammoniums and you now have 3 acetates. The 3 ammoniums is fine because if you look on the left side of the equation over here, you'll see that we also have 3 ammoniums right there. So this is balanced. The left side is balanced with the right side. As far as phosphate is involved, I have 1 phosphate here, and I have 1 phosphate here. So that's completely balanced. And then I have 1 iron, and then I have 1 iron. So these examples weren't too bad when it came to balancing. If it were me and they asked me for the sum of the coefficients, I would not forget that I have to put a 1 on all of these. So try not to forget that. It's an important principle. Sometimes they'll just ask you that to try to see if you remember how to do that. So don't forget how to do that. It's quite simple. Just make sure you put a 1 on the empty ones. So I'll go ahead and put a 1 here. I'll go ahead and put a 1 here. And I'll make sure to put a 1 over here. And now I can see that the sum of the coefficients would be 3, 4, 5, and 6. Okay, so this is the last and final step in double replacement reactions. I hope you found that by following these 4 simple steps, you can break this problem down and from what seemed a complex problem into a manageable problem with just 4 simple steps. I hope it's been helpful. That's the final step. So to summarize, there's basically rearrangement, there's crisscrossing of your products, solve for your product states where you find out if they're soluble or not, and then step 4 is to balance the overall reaction. Thank you for watching, and if you do have any questions, just please visit us here at the Tutoring Lab. Thank you, and I hope it's been helpful.